Let's look at the solution for this a very comprehensive question based on the working of potentiometer. Here in this potentiometer, the wire is given to be of length total 200 centimeters. And in the primary circuit, a cell of EMF 4 volts, an ideal cell of 0 internal resistance, and some external resistance are connected. And in the secondary circuit, what we say, a cell of EMF 10 millivolts is balanced by a length of 60 centimeters of the potentiometer wire. So of course, for 60 centimeters, we find the galvanometer to read 0. Now, when such a condition is satisfied, we are supposed to calculate the external resistance. What is that connected in the primary circuit? Here, by the principle of potentiometer, we know that the EMF in the secondary circuit equal to potential gradient along the length of the wire into the balancing length. Therefore, EMF in secondary circuit equal to the potential gradient is the V across AB, the potential difference along the wire AB, divided by total length of the wire AB into the balancing length is L. Further, this is equal to V AB, we can write as I primary. Because of this, a current I primary now comes in, I primary. Of course, the same now pass through it. So we say I primary into R of AB will give us V across AB, potential difference along AB, divided by L of AB into balancing length. Here, I primary we can write now in more elaborated way as follows. Therefore, EMF in secondary equal to, now I'll write an expression for I primary. So I primary is nothing but EMF in the primary circuit divided by total resistance, that is R of AB plus R external plus, if at all any internal resistance is there for that cell or internal resistance of the cell in the primary circuit, this all gives the current in the primary circuit IP into R of AB divided by L of AB, total length of the wire, into balancing length. Actually, this is the most comprehensive formula to be used in solving the questions based on potentiometer. This term stands for I primary. This is resistance of the potentiometer wire divided by length of the wire. Actually, I primary into R of AB divided by L of AB gives potential gradient into balancing length. Now, after having this formula with us, now we can go for substitution. Therefore, what is EMF in the secondary circuit? 10 millivolts. That is 10 into 10 power minus 3. This is equal to, what is E primary value? 4 volts divided by R of the wire AB is given as 10 ohms plus R external, that's to be determined by us, plus internal resistance of the cell is 0 into, again R of AB is 10 divided by length of the wire is given as 200 centimeters. So here let's write in meters now, that is 2 meters, 200 centimeters, I am writing in 2 meters. Here this length is 60 centimeters. Here remember, if this length is taken in meters, this balancing length should also be taken in meters. So 60 centimeters, I am writing as 0.6 meters. And now if we rearrange this data now, we get therefore 10 plus R external, this term now is here, if you simplify this expression, all comes to be 1200. Therefore R external is equal to 1190 ohms, and this 1190 ohms is present in option 2. So option 2 is our correct answer. Here you see the comprehensive question. If you are thorough with this question, you can easily solve the other questions also based on potentiometer. In a more elaborated way, the explanation is offered to you. Now go through it once, twice, and understand the way in which we arrive at the required answer.